A concrete road can carry heavy freight for 40 years, or crack in 5. The difference is not the concrete. It is everything that happened before the paver arrived. A full-line paving train laid 3.8 kilometers in Texas at 40% higher productivity than asphalt. But 90% of a road's lifespan gets decided underground. Watch to the end for a road built on top of a bladder. Two roads look identical from the driver's seat. One handles heavy freight for 40 years. The other cracks in 5. The difference is not the concrete pouring out of the machine. The difference is everything that happened before the paver ever got there. At Conroe, Texas, a continuously reinforced concrete link road, 3.8 kilometers long and roughly 7.9 meters wide, came together as a full-line paving train. Placer, spreader, paver, texture cure, all rolling forward as one connected unit. The project finished a week ahead of schedule with 40% higher productivity than the same crew's asphalt jobs. A paving train is not a marketing phrase. It is what happens when someone finally admits that pouring concrete one truck at a time is the slow way. Every station in that train exists because the station before it created a problem the next one has to solve, which starts with what nobody sees under the wheels. "90% of a concrete road's lifespan gets decided before any concrete arrives. Scarify the ground. Strip organic matter. Spread cement over the loosened soil. Mix, level, compact, cure." The subgrade below the pavement now behaves like a stiff base instead of a sponge. Skip this and the road cracks in 3 winters. 2 states, 2 different aggregate specifications. 1 mobile quarry that has to produce both. Screens sort the material to Florida road-based standards. A separate impactor handles the oversized rock to meet Alabama's rougher spec. Every gradation curve on a bag of aggregate translates directly into how long the road above it lives. Get the specification wrong, and the whole subbase already lost. A pulverizer chews the existing asphalt and base into a mixed layer. Water goes in. Cement gets spread. A vibratory pad foot roller compacts it flat. The old road becomes the new road's foundation. The animation makes it look tidy. Soil, cement, water, drainage, slope, roller. Reality is dustier. Cement bags get dropped in a grid pattern along the roadbed. Then a recycler tears through everything and homogenizes it in one pass. A motor grader shapes the profile with the drainage crown built in, because water sitting on a subbase is the same water that will freeze under a slab and lift it. A road that ponds water is a road already halfway to a repair contract. Compaction locks the mix, cure it right, and what was mud last week is now a working base. A site spreader towing a tanker distributes stabilizer along the shoulder in a controlled stripe, not by guessing. A grader mixes it into the base. Water truck sprays for compaction moisture. Compactor rolls the surface flat, then a sheep's foot works the deeper zone. The dust cloud looks dramatic. What matters is the density under it. After that, a chip spreader lays aggregate over a bitumen coat and a pneumatic roller seats the stones. Chip seal is not the road itself. It is the seal that stops water from finding the base below and undoing everything we just built. And here is where the engineering gets clever. A geogrid is a plastic mesh that gets rolled out over a prepared subgrade, then buried under aggregate. It sounds too simple to matter. It matters. When trucks pass overhead, the load spreads sideways through the aggregate. Without a grid, the stones migrate down into soft soil below and the surface starts rutting. With a grid, the aggregate interlocks with the mesh and refuses to move. You get more road life from the same base thickness, sometimes double. Installation is unglamorous. Bulldozer strips topsoil. Crew unrolls the grid, overlaps the rolls by the spec length, cuts around drainage inlets, and staples the edges down. Aggregate goes on top, gets compacted, and the road builds up from there. Nobody driving over it will ever know a plastic mesh is why their tires are not bouncing through a pothole. There is a different grid for a different problem: reflective cracking, where a crack in the old pavement propagates upward through a new overlay within a few winters. Used to be the reason road agencies stopped patching and just repaved the whole section. A fiberglass reinforcement grid laid between the tack coat and the new asphalt absorbs the strain from the crack below and stops it from telegraphing to the surface. Manufacturing runs from fiber extrusion through knitting, coating, and drying. Tensile testing verifies the grid can take what the road throws at it: thermal cycling, traffic load, freeze-thaw. Installation is a 2-lane closure and a slow morning. 20 years of extra pavement life for one afternoon of grid rolling. That is the kind of math road agencies notice. All of this happens before the concrete truck arrives on site, which is where the fun starts. Concrete does not come from a truck. It comes from a whole logistics chain, and the truck is only the last 3 kilometers. A self-erecting mobile plant loads a mixer in under 5 minutes. 3 aggregate bins, admixture lines, a 58-ton silo of cement, and a control system running hundreds of mix designs. Silos, conveyors, control panels, a mixer truck waiting under the discharge chute. The whole plant runs from one touchscreen, and the loader operator outside probably has no idea which mix he is loading today until the ticket prints. Automation removes the guesswork. Then there are the sites where the truck cannot get close enough to pour where the concrete needs to land. A telescopic conveyor belt mounted on the mixer chassis reaches out over the pour zone. Concrete rides the belt to the exact spot the formwork needs it filled. No wheelbarrows, no pumping delay, no crew jogging across rebar with buckets. The chute stops being a chute and becomes a delivery arm. 10 meters of extra reach turns a 2-hour pour into 40 minutes. 0.6 miles per hour. That is the top speed a mixer truck sometimes has to hold to feed a slipform paver moving at the same crawl. Crawler gears exist because nudging a 50-ton truck at walking pace is not what normal transmissions were built for. A volumetric mixer carries dry, aggregate, cement, and water in separate compartments and mixes on demand at the discharge point, meaning the concrete never exists until the moment somebody actually needs it. No waste from unused batches, no setup in a drum on the way over, no arguing over slump loss, small jobs, patchwork, remote pours. This is the way they get poured. A rural site with no ready-mix plant within economic distance. The volumetric mixer becomes the plant. Aggregate loads on site. Mix design dialed in on the control panel, concrete pours in the exact volume the pour needs. No leftover mud hardening in a drum on the way home. Now the concrete arrives at the site, and every choice made 2 hours ago at the batch plant is about to be judged. A surveying prism guides the paver for precise placement. A shot blaster preps the surface where the new concrete will bond to the old. A dump truck backs up to a spreader, which feeds the paver, which lays 2 lanes wide at once. Grooving and curing compound follow. Hydraulic cement pavement is the alternative to asphalt on routes carrying heavy freight. Lasts longer, costs more up front, and finance departments still argue about it every budget cycle. And here is the reveal most people never think about. Every truckload of pavement concrete has a stopwatch running from the moment it leaves the batch plant. Aggregate stockpiles get quality checked before entering the hopper. Calibrated scales weigh each ingredient to the mix design spec. Cement and fly ash come out of separate silos through pneumatic lines. Water and admixtures get metered by flow. The mixer drum turns for the required cycle count, then discharges into a truck stamped with a delivery ticket carrying the batch time. That time matters more than most people realize. Concrete starts stiffening the moment cement hits water. Cement hydration is a chemical reaction with a schedule. In normal weather, the crew has roughly 90 minutes to place the load on the road. In hot weather, the window shrinks fast. Slump tests happen truckside before the load ever enters the paver hopper. A load that fails slump does not get poured. It gets sent back to the plant, which is nobody's favorite phone call. Air content tests, cylinder samples logged for 28-day strength verification. Every step recorded on the delivery docket. The concrete you drive over passed 12 separate checkpoints before the paver saw a single cubic meter of it arrive. Then there is the mix designed to be pushed around by an asphalt paver instead of a slipform. Roller compacted concrete uses less cement than conventional pavement mix, and the water content is so low, the fresh mix has zero slump. It looks like damp gravel until you compact it, then it turns into concrete. A twin-shaft mobile plant handles the mixing because a normal drum truck cannot deal with stiffness this dry. Dump truck to spreader to paver to steel roller. Same rhythm as an asphalt job, and the finished surface reaches structural strength within days, which leads us to the machines that actually shape the road. And this is where a road stops being poured and starts being manufactured. A yellow slipform paver crawls forward, mixer trucks feeding it in sequence, workers finishing edges as the fresh slab leaves the back of the machine. Concrete goes in wet at the front and comes out shaped, textured, and ready to cure. The Yacuba Doble Via runs 3.47 kilometers, 25.68 meters wide, 6 lanes. Slab thickness 25 centimeters. The paver runs 250 to 300 cubic meters of concrete a day, laying 100 to 130 linear meters. 1 lane at 9.5 meters wide every day. Before the paver ever arrives, graders shape the subbase to profile. Backhoes trim the shoulder to width. When the slipform machine finally rolls onto the section, everything under it has already been prepared to the millimeter, because a paver moving forward at production pace has no way to fix what is wrong below it. Mixer trucks queue up. The production line starts. Inside a modern slipform paver, the concrete gets attacked in stages. A distributor plate spreads it across the width. A front gate meters flow into the mold. Electric vibrators, intensity adjustable, consolidate the mix. The mold shapes the slab. Then dowel and tie bar inserters plant steel reinforcement into the wet concrete on the fly. An oscillating screed smooths the surface. Everything happens between the moment concrete enters the front of the machine and the moment it exits the back, usually about 2 minutes. The batch plant sits right at the site, because trucking concrete an hour to the paver is trucking rejected concrete. A loader feeds aggregate into the hopper. Mixer trucks fill and roll straight to the paver. No detours, no waiting rooms. A water sprayer rides on the machine itself because fresh concrete in dry desert sun starts curing before you finish looking at it. The line advances. 3 ways to spread concrete inside the paver: a plow, a drive auger, or a twin auger. Each one handles a different slump range and volume. Adjustable mold edges compensate for the road's cross slope, so the finished slab has the drainage crown built directly into the pour. 35 centimeters of slab thickness. That is the pavement being built here, and the mix behind it is engineered to a flexural strength target of 48 kilograms per square centimeter at 28 days. A central mixer plant runs a 2-additive synergy. A Type D water reducer with a Type F high-range reducer, because getting the concrete workable enough for the paver without adding too much water is where the durability actually gets won or lost. Dump trucks carry the mix to site. The paver spreads, vibrates, and finishes it. A comb attachment behind the paver rakes a texture into the fresh surface. That texture is what will give tires grip after the curing membrane cures off. Curing compound sprays on last, sealing moisture inside the slab so the cement can finish reacting. Every layer of that surface has a job it will do for the next 30 years. And here is the moment when highway paving looks the most surreal. Traffic is running full speed, 6 meters away, one lane over, while a paver behind a plastic barrier lays a lane at walking speed. A concrete truck backs up to the paver, unloads, pulls away. Workers in high visibility vests walk the edge. The machine advances. The finished slab appears behind it as if it materialized. Nobody on the highway notices except the drivers slowing down for the cones. The lane they will drive tomorrow is being built next to them right now. Modern slipform pavers are not one machine anymore. They are modular platforms. A multi-purpose unit can reconfigure between road paving, curb and gutter, and canal lining depending on which mold and forming plate get bolted on that morning. 320-degree track rotation lets the machine crab sideways to line up on a start point without a crane resetting it. 90-degree steering handles tight urban corners where a rigid chassis would give up. Semi-automatic transport mode drives the machine between pours without needing a low-bed truck for every move. Telescopic end sections extend the paving width without swapping the entire mold assembly. Then downstream comes the placer spreader, which feeds concrete evenly across the paver's mouth so the mold sees a consistent flow. Behind the paver, the texture cure machine sprays the curing membrane and rakes surface texture in one pass. Together, they form the paving train, a moving factory laying road at the speed of a slow walk. At this site in Thailand, the setup runs on rebar mesh supported by plastic spacers. A continuously reinforced pavement. Steel stays in position through the entire pour. An excavator scoops concrete from the truck and drops it into the paver's hopper because the site geometry does not let the truck reverse directly onto the mesh, which is fine. A 20-ton excavator with a bucket makes a very expensive shovel, but it makes the shovel work. The paver's finishing mechanism trails multiple pipes that dispense concrete evenly across the width. As the machine advances, a smooth slab appears behind it, the vibrators already off, the surface already textured. Workers walking the edge do hand finishing on the outer 10 centimeters. That is where the machine cannot reach. Everything you saw the concrete truck deliver 2 minutes ago is now road. The next mixer is already pulling up. Airport aprons and taxiways use the same paver family as highways, but the mix is stiffer and the tolerance tighter. A jet loading gate has more weight per square meter than any truck a highway will ever see. Behind the paver rolls the texture cure machine, spraying the membrane and grooving the surface for grip. Same principle as the road, different customer expectations. And finally, the technology that killed the string. Stringless paving uses GPS and total station tracking instead of guide wires. No more crews stringing kilometers of line ahead of the machine. The paver knows where it is to the millimeter. The same slipform principle, scaled down. A small extruder machine forms a continuous concrete channel along the edge of the road. Drainage, curb, or channel wall. One machine, one operator, one pass. The channel appears behind the machine like it was always there. A highway is not just the surface you drive on. Every shape along that road, the barrier, the curb, the gutter, the drainage flume, has its own dedicated machine. A 4-track barrier paver extrudes a concrete safety barrier in one continuous pour next to live traffic at walking pace. Concrete drops onto a conveyor belt, feeds into the mold, and comes out the back as a finished barrier with rebar conduits already embedded for later couplers. Slipforming a barrier is the same principle as paving the road. Workers finish the top edge as the machine advances. Then there are the shapes no standard machine covers, and this is where custom drums earn their keep. A curved drainage flume gets formed by a rotating drum that rolls along the side forms, compacting and shaping the wet concrete into whatever cross-section the drum is cut for. Workers pour, spread, and let the drum do the finishing. 600 feet of flume in 4 hours on a first-time crew. That is what happens when the tool actually matches the shape. Roller screeds cover more work than most people realize. Curbs, edges, channels, ditches, circular pours, all with the same rotating drum, changed out for the profile the pour needs. Hydraulic, battery, or corded, depending on the site. For power grid expansion work in northern Colorado, the drainage flume needed a specific deep profile. An excavator lowers an inflatable bladder into the trench to hold the interior shape. Concrete gets poured around it, and a custom drum 18 inches deep by 132 inches wide rolls along the top on a wheel trolley, compacting and finishing the surface. The bladder deflates, comes out, and the flume is done. And here is where the same technology walks off the highway and into industrial estates, logistics, yards, and warehouse floors. Macropolis Atapa 1 alone required 292,000 square meters of concrete pavement. Each slab is 17 centimeters thick, with steel fibers mixed into every batch for added strength. 104,000 square meters of urban avenue at 16 centimeters slab thickness. Dowel bars, 1 inch by 45 centimeters at every 30 centimeters across joints. Tie bars, 1/2 inch by 60 centimeters every 60 centimeters. The pavement carries traffic. The dowels carry the load between slabs. That is what stops joints from stepping. A rural avenue paved by mixer truck and screed machine, straight through the night under floodlights because the daytime heat pushed the crew off the pour window. Concrete stiffens with heat, so the schedule flips to night whenever the sun refuses to cooperate. Joint sealant goes on last, sealing every expansion cut against water intrusion for the next 30 years. Industrial slab pour inside a warehouse shell already built. Formwork sets the perimeter, rebar goes in, and the mixer truck pours from the outside. Power trowels take over for the surface finish because a factory floor has to be flat to a tolerance road slabs never bother with. Forklifts run all day on that slab. Any lump in it becomes an argument about warranty later. Logistics platforms are where slab construction turns into serious volume. A warehouse floor for freight distribution has to carry loaded trucks, forklifts, and racking loads for decades without cracking or lifting. Steel framework goes up while the ground crew works below. Concrete pours in sections separated by expansion joints. Laser screeds handle the leveling because eye and hand are not accurate enough at this scale. One high spot and a forklift starts bouncing goods off the shelf. Power trowels follow behind, tightening the surface. Saw-cut joints appear later, before shrinkage cracks decide where they want to go on their own. A concrete pump truck reaches over the rebar mat and delivers concrete exactly where the crew needs it, on a foundation slab spanning multiple industrial bays. The pour runs 7 consecutive days because a slab of this footprint gets divided into placement bays to control shrinkage and heat of hydration. Pour it all at once, and the middle of the slab is still curing when the edges have already gone cold, which is how internal cracks form invisibly. Sectioned pours let the heat escape between bays. And here is the payoff for a small town most people have never heard of. An urban improvement project in Andahuaylas rebuilds 4 blocks into full concrete pavement. Road surface, curbs, sidewalks, drainage channels, crosswalks, and speed bumps, all in one continuous project. On-site batching plant. Mixer trucks feeding a screed line. Power screed pulls the finished surface flat. Edges get hand troweled. Expansion joints saw cut in a grid before shrinkage cracks pick their own spots. What used to be dirt streets is now permanent infrastructure that will still be there when the crew that built it retires. Double mixer discharge into the paver. Quality lab on site running slump tests, temperature checks, compression cylinders. Every batch that leaves the plant has to prove itself before the paver accepts it, which raises the question: is there a faster, cheaper way to lay pavement this durable? And the answer is yes, for the right applications. RCC uses less cement, no rebar, no forms, no dowels. An asphalt paver lays it. A vibratory roller compacts it. A power trowel smooths the surface. Same day, structural strength reached in days. Ports, logistics, yards, heavy freight lanes. This is where RCC keeps showing up. Lower cement content, lower CO2 footprint, lower material cost. The mix comes in stiff as damp gravel. The paver spreads it, the roller compacts it, and hand tools finish the edges. The finished pavement carries heavy loads with almost no maintenance for decades. That is why owners of freight terminals keep asking for it by name. A road is never really finished. It just enters its next phase. Precast pavement panels get lifted by excavator from a flatbed and lowered into position over a prepared base. Replaceable, removable, and faster than repouring on site. The mixer truck is the constant of every concrete project. New construction, panel replacement, patch repair, spot pour. Every generation of these vehicles gets a little smarter than the last. Inside the factory, plasma cutters slice steel sheets into shape. Rolling machines bend them into the curved drum sections. Robotic welders join the seams at accuracies. No hand welder can match on a repeatable line. The finished drum gets craned onto the truck chassis, and workers handle the final assembly manually. Hydraulic lines, control valves, chute mechanisms, gearboxes. The reason a road built today looks so different from one built 40 years ago is not just the paver at the front. It is the truck delivering the mix to that paver. Lighter, better balanced, more precise on discharge rate. Every road built or repaired anywhere still starts with one of these arriving on site. And so the Conroe Link road we opened this video with is now doing its actual work. 3.8 kilometers long, 7.9 meters wide, continuously reinforced concrete pavement, finished a week ahead of schedule with a 40% productivity gain over conventional methods. Trucks are already running loads across it. Everything you saw across this video, from subgrade to paver to finish, was for this moment. Every kilometer of concrete road standing today is built on decisions almost nobody thinks about. The subgrade specification, the mix design, the joint spacing, the curing time, the panel replacement plan 30 years out. The road you drive on tomorrow is only as good as the ground beneath it was 30 years ago. Long before the first truck rolls across it, its lifespan has already been decided. That is why the most important work often disappears beneath the surface. If you were building a brand new highway today, would you choose concrete or asphalt? Why? Drop your answer in the comments. Engineers, contractors, and anyone who has watched a road get repaved twice in a decade probably has a strong opinion. Thanks for watching all the way through. Hit subscribe if you want to see how the next kind of infrastructure gets built. See you on the next one. Take care.